Hello guys, this is a video of some selected problems from the two assignments about regular polygons. So this is section 10.3 problems on page 631. I just picked out some that might have given you some troubles. So here is the formula, 1/2 times perimeter times apothem. They don't give you the perimeter directly, but they tell you it's a pentagon, which has 5 sides, and the side length is 35.3. So the perimeter is going to be 5 sides times how long the side is, 35.3. And then that is going to give you 5 times 35.3 gives you 176.5. And so I'm going to plug that in for P. 1/2 times 176.5. And then the apothem was given to you, 24.3. So then you multiply those times 24.3 times 1/2. You get 2,144. I didn't look up what it said to round to, but it gives you this. And so I'm going to round it to the nearest tenths. That would be centimeters squared, because remember this is area. All right, so one of the common mistakes I see with this is that people will put the side measure here, the 35.3, instead of putting the area. So make sure you perimeter. Make sure you calculate the perimeter to go there. All right, 21. There are several different ways to do this problem. So I'll show you what the intention is. The intention is to use the new formula, 1/2 perimeter times apothem, but since that thing is a square, you can also do base times height, and you can also do 1/2 diagonal 1 times diagonal 2, because a square is a rhombus. That would probably be the easiest thing to do here, because if that is 6, so is this right here. So the diagonal's 12, and you can just do 1/2 times 12 times 12, and you could have the area really quickly that way. So that's one way to do it. You could also find base times height. But they're wanting us to use this formula, so I don't have either of these values, perimeter or apothem. So I'm going to draw this triangle right here. And if you remember in our little preview lesson, we calculated this central angle. 360 divided by 4 is 90. So that's a 90 plus, that's what happens inside any rhombus. You get a 90-degree angle when the diagonals cross. So that's 90. And then when you split that in half, you have a 45 right here. So I'm going to draw this little half triangle. And this was the original 6 that they gave me. And this is a 45, 45, 90. So if they give you the twice A side, the A radical 2 side, that's supposed to have a radical and it doesn't. So remember that shortcut from chapter 8, you divide that by 2, and that gives you a 3, and then you stick on a radical 2. And that's what these measures are. That just gave me apothem. And since this is 3 radical 2, that whole thing is 6 radical 2. And then the perimeter is 24 radical 2. So this is 1/2 times 24 radical 2, because it's 6 radical 2 4 times. And then we're multiplying it by 3 radical 2. So this is what you're multiplying. 1/2 times 24 times 3 is 36. And radical 2 times radical 2, radical 2 times radical 2 gives you just plain old 2. Because there's twins in jail, so one comes out. So the answer is 72. Hold on. 12 times 12 is 144, half of that. Yeah, I thought I messed up because I was thinking 12 times 12. If you had done 1/2 diagonal 1 times diagonal 2. But that is 144, and half of that is 72. So yeah, 72 centimeters squared. Okay, this one is a hexagon. They gave us the radius. I don't really like how they drew it in the book, so I look at it like that. That's the radius. So in our little preview lesson, we that intro lesson to 10.3 and 10.5, we found this angle. That is 360 divided by 6, which is 60 degrees. And then when you draw that apothem, it makes this little half triangle with a 30 right there. And this is strange. It's a 6 radical 3. That's strange. Okay, so across from the 30, this is A. The A radical 3 side is supposed to be over here. A radical 3. This side is the twice A side. This is twice A. So it just makes it, this problem's a little complicated because of that weird radius that they gave us. So if twice A is 6 radical 3, then plain old A is 3 radical 3. So that's what that is. And that means the apothem is that whole A value, 3 radical 3, with a radical 3 on it. So see, that just got weird. But the 3 radical, radical 3 times radical 3, that's just a 3, times that 3 makes that a regular 9. That is just a regular number 9. All right, so now I've got everything I need. I just have to plug it into this formula. So here's the area formula. Okay, this 3 radical 3 is right here. That's what that is, which would be half of this. So this is 6 radical 3. And you could have gotten there sooner if you remember that will, in a hexagon, only in a hexagon, this will be an equilateral triangle because that's 60 degrees. And the two radii are the same. So this will, in a hexagon, will be an equilateral triangle. So whatever the radius is, so is a side. And there are 6 of them. So if one side is 6 radical 3 and there's 6 of them, that is 36 radical 3. And then the apothem is 9, and then you just have to multiply those. Half of 36 is 18, and 18 times 9 is 162. 162 radical 3. I didn't write any units on this, so it's units squared, unless they had units in the book and I just forgot. Area, units squared. Okay. This is kind of like the square problem. There are other ways to do this problem. You could find out what this whole height is and what this base is and do 1/2 base times height. They want us to use this formula, 1/2 perimeter times apothem. Okay, so this is the triangle that I draw, this right here. This angle is 360 divided by 3, which is 120. And then when you draw in the apothem, it splits that. And that is now a 60-degree angle. And that they gave me the 4, that's a radius, so I can put it here. This is a radius, 4. And now I can find these missing sides. So across from the 60, this is A radical 3. Across from the 30, this is A. Across from 90, this is twice A. Twice A is 4, so A is 2. I just found the apothem. And this is 2 radical 3. So that right there, 2 radical 3, is this distance. So the whole side of the triangle is 4 radical 3, and there are 3 of them. So that is 12 radical 3. And the apothem is 2. Anytime you have a half and a 2, that's nice. They cancel. Half of 2 is 1. So the answer is 12 radical 3 inches squared. If they ask you to give this as a decimal, you just punch that into a calculator and give your answer as a decimal. All right, number 31 says there's a gazebo. The gazebo is a regular octagon. You don't have to draw it because, see, they're giving us all this information. I'm just going to go straight to the formula. It says the area is 310.4. So you plug it in for A. They did not give me the perimeter directly, but they told me it's an octagon and the side is 8. So if there are 8 sides and each of those sides is 8, then that's a 64 for perimeter. And it says find the apothem. So good news is the apothem is what is missing in our formula, and all we have to do is solve this using some algebra. Half of 64 is 32. Divide by 32. And that will give you your apothem. 310.4. Divide by 32. You get 9.7. This would be feet. Okay, so those are the problems that I selected from page 631. Number 37 is the same problem as number 21. It's just it had a different radius besides 6, but it was the same drawing. Okay, on lesson 10.5. And I forgot to mention that when I do these videos where I'm just going over questions, you absolutely do not have to sit and watch the whole thing. Just fast forward through it and find the ones that you needed some help on. Okay, so a nonagon. Now these shapes, 9 sides, 20 sides, 15 sides, I cannot draw those things. As soon as I get past 8 sides, the drawing looks terrible. So I'm just gonna pretend there's this, nonagon, and there's this 20-sided polygon out there, and there's this 15-sided, I can't draw it. So what I do is I draw this triangle. So that triangle that's formed by radii, this is called the central angle. You're going to divide 360 by 9, and that's going to give you this angle right here. That's 40 degrees. And then when you draw in the apothem, that gives you a 20-degree angle in this little half triangle right here. That's a 20-degree angle. The radius is 7. Okay, so here's the problem. We need the perimeter and we need the apothem. So radius, these are the hard questions, and most of these questions on this homework, that's what they gave you was radius. So it takes a little bit of work. All right, I want apothem. I'm going to call this X. That's going to eventually give me the side, which is going to give me the perimeter. Okay, here's my angle. So I'm going to use a sine problem to get X, because I'll use opposite and hypotenuse. So sine of 20 equals X over 7. And I'm going to use a cosine problem to get A, because that's adjacent and hypotenuse. So cosine of 20 equals A over 7. So when I do these two problems, I'm going to get this measure and I'm going to get the apothem. So 7 sine of 20 is 2.4. The best thing to do is leave about, I'm going to do 4 decimal places. 2.3941. And then this one, 7 cosine 20, 6.5778. Okay, so now when I plug these into the formula, I've got more numbers and I can round at the end. All right, so let's talk about what X is. X is a half of a side. So double that thing, 2.3941 times 2. That's how long a whole side is. And there are 9 sides. So what I see, the biggest mistake I see is people plug that in for perimeter, but that's just one side. So multiply it by 9 sides, and this is your perimeter. So I've lost some, I don't have enough room, 1/2. Sorry guys. Perimeter is 43.0938, and I'm multiplying it by this apothem, 6.5778. So divide that thing by 2. That's a half of it, times the apothem, 6.5778. 141.7, approximately 141.7 inches squared. So you need to leave yourself some room, and I need to see some equations for finding these measures and see the 1/2 perimeter times apothem. That needs to be shown. Okay, same kind of problem. That's how you do these. You're gonna draw that triangle. 360 divided by 20 gives you 18. So this is 18. And then when you draw in that apothem, you've got a skinny little 9-degree angle right there. 9-degree angle, the radius is 2. So it's just like the last one. I'm gonna need sine and cosine to find the apothem and this little half side. So to find the side, you're gonna go sine of 9 equals x over 2, and you're gonna do cosine to find a. Cosine of 9 equals a divided by 2. So this is 2 sine of 9, this is 2 cosine of 9. 2 sine 9, 0.3129. 2 cosine 9, 1.9754. Okay. Okay, here's what I've got. The x is this value, which is half of a side, 0.3129. So what I'm going to do with that number is I'm going to double it to get the whole side. Oops. And then I'm going to multiply it by how many sides there are. It's a 20-sided polygon, so times 20. This is the perimeter. And so plugging into the formula, 1/2 times that perimeter, 12.516, times the apothem, 1.9754. So divide that by 2, multiply it by 1.9754. 12.4. Yeah, because it was half of almost 2. So that almost canceled. So it's about the same as what the perimeter was. This is millimeters squared. Okay, number 13 is a 15 gone. Again, cannot draw that thing. So there's the triangle. If you divide 360 by 15, you get 24. 360 divided by 15, 24. And then when you draw in the apothem, that gives you a 12-degree angle. All right, they gave us something different this time. The perimeter is 180. And if there's 15 sides, 180 divide by 15 sides gives you 12 for each side. So that right there is 12, which means this is 6, and that's what I'm going to need to use to find my apothem. This time to find the apothem, it is a tangent question. So tangent of 12 equals opposite over adjacent, because in relation to that angle, this is the opposite, this is the adjacent. The variable's on the bottom, so you divide. So what you type in the calculator is 6 divided by tangent 12. 6 divided by tangent 12. You get 28.2. The apothem is about 28.2278. And then the formula would be 1/2 times the perimeter. They already gave us the perimeter, 180. And the apothem we just found out to be 28.2278. So 180 divided by 2 times 28.2278. 2540.5 centimeters squared. That one was a little bit easier because they gave us the perimeter already and we didn't have to do trig twice. We only had to do the trig one time to get the apothem. Number 23 looks exactly like this problem, number 25. So it was a equilateral triangle where they had given you the radius. So same problem. And then number 25. This one I could actually draw because it's a hexagon. Here's that triangle. 360 divided by 8 gives you this angle right here, 45. And when you draw in the apothem, it splits that 45-degree angle in half and gives you a 22.5-degree angle. They gave us radius again. So to get the apothem and the side length, it's just like these problems up here. We have to do trig twice. So to find this, we're going to use sine. Sine of 22.5 degrees equals opposite over hypotenuse, and cosine of 22.5 is adjacent over hypotenuse. So we're doing 10 sine 22.5 is 3.8268, and 10 cosine 22.5, the apothem is 9.2388. And then we're going to plug these into our formula. Remember what you've got when you have x. You only have that little half side. So 3.8. We're going to take that number and double it. I have like 3 problems. It gives us that. That's how long a side is. And it's an octagon, so there are 8 of them. We multiply that by 8. That gives you the perimeter. So we're ready for the formula. 1/2 perimeter times apothem. 1/2 times 61.2288 times that apothem that we calculated, 9.2388. And this is what we're multiplying. So divide that thing by 2. Multiply that by 9.2388. 282.8. And this is measured in meters, meters squared. Number 27, pentagon problem. It says the Pentagon, the one in Washington, has sides that are 921 feet long, and they want the area of it. So, drawing this triangle, calculating that central angle, 360 divided by 5, that gives you a 72-degree angle. And then when you draw in the apothem, that gives you this 36-degree half triangle. And remember, that's going to split that 921 in half, which gives you 460.5. And we're looking for the apothem, so we're going to use trig. This will be a tangent question. So tangent of 36 equals opposite over adjacent. And since the variable's on the bottom, we're going to divide. 460.5 divide by tangent 36 gives you this for our apothem. 633.8239. And now we've got everything we need for our formula. 1/2. One side is 921, so multiply that by 5 to get the perimeter. 921 times 5. 4,605 feet times this apothem, 633.8239. So divide the perimeter by 2, that's half the perimeter, multiplied by that decimal, 633.8239. Gives you this number. Hold on, let me make sure I multiplied that right. 4605, divide that thing by 2, times 633.8239. Yeah. So this is the area in square feet. And I think they wanted nearest 1,000, so they want it rounded to there. 1459000. Let me make sure I did that right. Yep, because to round it here, you would look at that number. 1,459,000 square feet. All right, last one. They want this shaded area. So we take the big pentagon, find its total area, and then we find the little pentagon and find its total area, and then you just subtract them. So that work will be a whole lot like the pentagon problem. So we're gonna have the 72-degree angle, which splits in half to the 36. So you'll use that same process to get the area of the big one, and then you'll use that same process to get the area of the little one, and then you just subtract, because when you subtract out that little one from that big one, it's gonna leave this shaded part. So that's how you do number 37. All right, so that is some of the homework problems from 10.3 and 10.5, so I hope that helps. All right, y'all have a great day. Bye.